Hello guys, welcome back to another video. And in this video, we're going to be talking about physical quantities and units. I'm just going to touch on the conceptual understanding of what is a physical quantity and what is a unit. That is the unit of a physical quantity. So let's get into it. So the first thing we have to understand, when we say physical quantities are different from physical units. But rarely will you come across the term physical units. You only come across the term unit or basic unit or derived unit. Physical quantities are things like length, things like mass, things like current, things like temperature, things like force. Basically, the things we want to measure in nature. That's what we call a physical quantity. Those are the things we give the term physical quantity. So again, things like mass, length, temperature are physical quantities. Now, why do they call them physical quantities? Now, number one, the things exist in physical reality. They exist in the physical reality. Now, because of that, they deserve or they take the term physical first. Now, why quantity? The term quantity comes because we want to measure these elements of nature, these physical elements of nature. So say we want to measure temperature. We want to know how much of temperature we have. So we want to measure the quantity of temperature. Hence, we give the term physical quantity. Anything we can measure the amount of, like any physical thing we can measure the amount of, deserves the term physical quantity. So the term physical comes from the fact that this is something that exists in reality. And the term quantity comes from the fact that we can measure this, we can measure its amount. This physical thing, we can measure its amount. Then when it comes to units, or unit if you will, when it comes to measuring anything, be it force, be it temperature, be it length, time, mass, when it comes to measuring anything, we need a standard or a basis or a foundation, if you will. But I think standard and basis are the perfect terms here. Say for example, we want to measure length. Now, we cannot just design an instrument that measures length without a basis, without a standard. What do I mean? Say we are in the primitive era or in the historical era, like way back in the past, and we want to measure length. This is a duster. I could use a duster to measure length in this way. I would come and put the duster. Say I want to measure the length of this board. So I want the length from this point to this point. I would use a duster this way. I would come and put the duster here and mark it off. So from this point to this point, this length is equal to the length of the duster. And then I'll put the duster here and I'll mark off the point. So this length to this length to this length, in other words, this length is equal to the length of two dusters. D is for dusters. So if I go on and mark on, and mark, and mark, and mark, and mark. So what do I have? I've got 1, 2, 3, 4. I know you can see this. 5, 6, 7. So using this duster, I was able to measure 7 parts that make up this entire length. So we've got 1, 2, 3, 4, 5, 6, 7. So consequently, I would say the length is 7 dusters. The length, that is the distance from this point to this point, that's what we're referring to as the length. The length is 7 dusters. Now, we might choose something else instead of a duster. We might choose, say, a pen. Let's say we put a pen. Roughly a pen is has the same length as the duster. So we could repeat the procedure. And when we're done, we would get, say, 7 pens. Now it depends on the length of the thing you're using. If you're using something smaller, say a chalk is roughly half the length of a duster. So you'd end up, say, with 14 chalks as the length of the board. Now, the standard we use in physics when we're measuring length is called the meter. Now, what is the meter? The meter is simply this. Say we decide to stick to our duster. Now, our duster has a certain length. From this point to this point, it has a certain length, but we're not going to measure this length. We're not going to take a ruler and measure the length. We just know that it has a certain length. And let's assume that this length doesn't vary, it's fixed. This thing doesn't expand with temperature or contract or anything like that. It's fixed. So from this point to this point, we've got a fixed length. Let's call this length, we're not measuring it, let's call this length a meter. This length from this point to this point, which we never measured, by the way, we're just calling it a meter. We know, what do we know about the meter now? We know, since we said our duster doesn't expand or contract with temperature, or doesn't suffer any distortion, we know that the meter will always be fixed. So instead now of saying or using the unit D for dusters, we can simply replace D with M, since we're now calling our duster the meter. That's all there is to the unit meter, like that's all there is. Like everything, it's that simple. So what do we learn here? The unit or a unit of any physical quantity whatsoever, be it length, be it mass, be it time, is a basic starting point we have to use whenever we have to measure anything. So our basic starting point in this case is the duster. So this is our unit. Like we say, this is what we'll use to compute the length of the entire board. So if it were, let's take another example. If we were talking about, say, time. Now time, in order to measure time, it's a bit tricky at first, but get used to it so that it becomes ingrained in your brain and it becomes super simple. So in order to measure time, the most natural way, which has been abandoned by the way, but the most natural way is to use the sun. Why? Why do we use the sun? Because the sun repeats its cycles in a way, so to speak. It's repetitive in its behavior. So in order to measure time, we need things that sort of like repeat their behavior or perform some kind of cycles so that we know that, okay, this thing is now repeating its cycle. So a certain amount of time has elapsed. We do not know how much, like, okay, let me not delve into the details. I want to stick to a basic conceptual understanding of this physical quantity. Let's go further. Say we've got the sun. We're going to use the sun to measure time. Now, a lot of you may be familiar with the hourglass, where we have sand inside the hourglass. And the sand would be like pouring into this bottom part, coming from the top, pouring into this bottom part. Now, we could create an hourglass and begin pouring in sand. Like, maybe we'll make the hourglass like big enough. Say this is the bottom part is very huge, and the top part is proportionally huge, equal actually. What we will do in order to measure time using the sun, we'll do this. We could pour in sand, say from a certain point. Okay, say when the sun is directly above us, we'll begin to pour in sand inside this hourglass, and the sand will be going into the bottom part. Up until, now this is just theoretical, it's not very, very practical, it's not the most practical way to do it, but we would do it up until the following day when the sun again is at this point, and then we'll stop pouring sand. The moment you stop pouring sand, we'll then flip it. So now we know that the sand inside the hourglass, like in order for the sand to go from the bottom part to the top part now, when we are flipped, it will take an entire day. How do we know this? Because when we began the process, the sun was right on top of us, and we poured sand inside up until the following day when the sun was on top of us. So this would become a measuring instrument of time. What would be our unit in this case? Our unit would be a day. That would be our unit of time. It would be a day in this case. We could use something smaller. Okay, why am I saying it would be a day? Because it is the basis through which we measure the time. Does that sound like intuitive? I hope it does. Why am I saying this hourglass filled with sand uh, can now be used as the unit of time? It's because we know that it takes a certain amount of time. We do not know how much, but we know that that time is equivalent to a day. Just like we didn't know the length of the duster. We just called it a meter without measuring it. We can do the same here. We just know that the amount of sand in here takes a day to get emptied from one space of this vessel into another. I hope, guys, I'm not like I'm not the best teacher. I'm not the best teacher, but I'm trying to make you get an intuitive sense of how we come about or how we come up with things we call units, like when we're trying to measure the physical quantities in nature. So time is a physical quantity. We know that because it's something that exists in reality. We can all agree that time is moving, time is elapsing. So it's something that's physical. And the quantity part comes when we begin trying to measure it. And through this, we know that we're able to measure it. Now, we now have sophisticated methods of measuring time. Not necessarily sophisticated, but better methods of measuring time. Better than this. The same applies for length. We now have something better than a duster. We've got rulers and some sophisticated equipment for measuring length. So that's it, guys. I just wanted you to have like an intuitive feel for where these two things come from, or where these two concepts in physics come from, and why they are important. So basically, the importance is clear from what I've been saying. We cannot talk about physical quantities if we do not have the basis of measuring them, which are the units basically. Now, when you are writing in your exams the definition of a unit, don't say it's the basis of a measurement. No, that would not do. You'd have to check with your exam board, like the definitions they expect you to give when it comes to this and this. The definitions I'm giving here are just to give you an intuitive feel, a conceptual feel, like a real understanding of how this and this works. Now, you might come across, this is a bit advanced, you might come across a situation where they say the meter is the distance traveled by light in a specific time interval or in a certain time interval. Yes, it's true, but that definition doesn't give the student who's being exposed to physics for the first time a really intuitive understanding. So that's why I decided to make this simple breakdown of what units and physical quantities are, because believe it or not, or whether you want it or not, we are moving fast. Like in terms of information, in terms of knowledge, we're moving fast. So a lot of people might seem like it's not a good idea to keep using, say, the duster example as a way to introduce the concept of physical quantities and units. But I think it's very, very, very important because that's where these concepts emerged. So just bear that in mind when it comes to physical quantities and units. A unit, like I said, I'm going to repeat, is a basis, is that starting point that you need to have in order to begin measuring the physical quantity. We cannot talk about this when we do not have this. This does not exist without this. So I hope I gave you an intuitive feel. Now, in some other video, I'm going to get into the details which are necessary for you to, say, write an exam and pass. But this video was simply focused on giving you an intuitive feel when it comes to dealing with physical quantities and units. Thank you, ladies and gentlemen. Please leave a like, subscribe, and comment if you enjoyed the video. Have a nice one. Stay motivated.